The question of the day: is El Nino fading or just taking a pause? I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Monday, May 29th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. And if you'd like, send a little money our way. We'd appreciate it. Use the special thanks button down below, the heart with the $sign in it. With that, I'd like to take a moment to thank folks that have donated this past week. Russell Harju, thank you very much. Baja Bugs, of course, thank you. Sporeman, Jason, thanks again. And then special shout out to Benjamin Brooks, who donated generously this week. We really appreciate all your contributions. And with that, let's get to work. We'll start by looking at significant wave heights for the South Pacific Ocean. We see remnants of a gale that previously was in the Southern California swell window, Southern California being about 118 west right here. So this is well east of there. Not producing swell anymore for the U.S. West Coast, but certainly still producing swell relative to Peru and Chile and Central America and, of course, Mexico. And then a new system starting to develop again in the far southeast Pacific. That has been the trend of this entire summer so far, for the most part, with like 7 different systems now just back to back to back, all in the very far southeast Pacific. That is very typical of La Nina. High pressure takes over the area around New Zealand here, and then the jet lifts off to the northeast, opening up a little window right here. Systems form, lift off to the northeast, sort of bypasses Hawaii, barely affects California, really focuses on Central America down into South America, and that's exactly what's been going on lately. Now, the flip side of that is during El Nino years. Once El Nino is well established, the exact opposite happens. Low pressure sets up right here. The high shrinks instead of covering this whole giant area, covers a smaller area or shifts off to the west, and the opening, the trough, the spot is right in here, which gets more of a southwest angled swell type thing going on, opening up a window for Hawaii, and then, of course, all of California, and again, South and Central America, but not as favorable direction, being more southwest and much further away. So the trend right now, atmospherically, is clearly a La Nina base trend. Current conditions, we're just looking now pretty much at southern hemiswell because there's nothing of any interest coming from the north. So we'll start in Northern California. The Point Sur buoy, number 157. This favors areas like Santa Cruz and southern San Mateo County, that sort of thing. We're looking at all the energy that's hitting that buoy. We see a definite bump here at 18.2 seconds, so 33.3 second period. That's really super long period swell energy. There's, what, a tenth of a foot there. Most of the energy right here. And then this chart goes the whole way down to 5 seconds. These are the height of the swell in feet at each of these different period bands. Okay, so we see another little bump here at 8 to 9 seconds, like 1.9 feet. I mean, it just rough rule of thumb, you can almost double whatever the peak energy is, and that'll pick up whatever's over on the shoulder on either side here. But we do that math for you as well. So wind swell, a little bit of southern hemi swell. Here we go. Primary swell, 2.4 feet at 17.5 seconds from 169 degrees. That's probably a little overstating. It's more like 175 or something like that, but pretty much shadowed at many breaks in Northern California. And that would result in surf that's about 4 feet, and that's about the right size. I mean, there are some shoulder to maybe near head high sets if you stretch it. And then the secondary swell, 3.6 feet at 8.2 seconds from 319 degrees. That's that wind swell at about waist high. Then we go down to Southern California, Point Loma South. This is like off San Diego, buoy 191. good just general looker for anything, any south swell pushing up into Southern California. See again this swell, very south angle sitting right here at about 16.7 seconds. The primary swell 3.2 feet at 16.7 seconds from 178 degrees. That's a good angle there. Surf from primary swell 5.4 feet. Yeah, there are head high, maybe a foot overhead sets, but the system that made this, not super strong, not pushing super hard to the north, not a very energetic system. And so it's pretty good long wait between sets and not a whole lot of waves with per set. Then we go over to the south shore of the Hawaiian Islands. We're using the Lanai buoy number 239 because that's protected from any wind swell, and it's still pretty valid for whatever might be going on in Oahu. Now we see energy here in the 15, 16 second period range, that sort of thing. This is energy that snuck up through the Tasman Sea. Primary swell 2 feet at 15.8 seconds from 218 degrees. That clearly is, if you go map out all the great circle charts and that sort of thing, this is clearly in that originated in that Tasman Sea window. Fiji, of course, sort of blocks some of that, so it gets filtered out. Primary surf 3.2 feet. There's definitely some chest high sets on the south shore of Oahu, and rideable surf. So where did these swells come from? We're going to go take a look back in time. We're using the altimetry data because this actually goes back about 10 days, where the wave model only goes back about a week, 180 hours, something like that. So here is the first system that developed on the 19th of May here in the deep south central Pacific. It pushed off to the southeast. You can see we actually got some Jason 2 satellite passes over top of this. We see seas at 26.9 feet on one particular slice. You can barely see the little slices here, with a 15 reading average at 33.3 feet. And then we'll see if we can get this back into motion here. And then that system pushed off to the right here. So there's about 118 west is right there. We got a couple of passes over the system again. That was on the Sunday, the 21st of May with, let's see. So this is, says 42 feet right in here. Find that hard to believe. That might be the one max measurement. I mean, if you get multiple waves in a storm, they all kind of double up on top of each other. That gets you like a rogue wave. That's what that is. At max average measurement says 36.2 feet. And some of that's like more over here, even outside the Southern California swell window. Then the system, here we go, lifted north on Sunday out of the Southern California swell window. Then we had a little blip. Now we're going to go back. We're going to go see what also happened. We're going back to Saturday, May 20th. You see a gale trying to push up into the Tasman Sea on Sunday, the 21st of May. But then there was a little bit of an outage of data, and we lost it into Monday night. But whatever pushed up through here, that is the origin, or this is the storm that created the swell that's currently hitting the Hawaiian Islands. And then two days ago or so, on Saturday, May 27th, another little system developed here again, right on, there's the end of the Southern California swell window is right about there. Tiny little system blew up here with like, 31 feet, maybe 32 feet this morning. 31 foot with a single measurement to 35.9 feet, but at 116 west. So that's mainly east of the Southern California swell window. But you get the sense that yet more surf is developing, aiming towards Southern California, and then yet another system developed behind that. We'll pick that up here in just a moment. So what's coming for the next week? Well, we're going to start by doing upper air analysis, jet stream level wind analysis. The jet stream, those are winds up at 30,000 feet. They help support the formation of gales. When those gales form, help direct their track. We're looking for trough, a push in the jet to the north. Why do we care about that? Well, these winds pushing to the north help create an eddy aloft. And that eddy would be in a clockwise rotation. And a clockwise rotation in the southern hemisphere is the sign of low pressure. Low pressure, if it's deep enough, also manifests itself down at the ocean surface. That generates winds. Winds get traction on the ocean surface. They generate seas. Seas, as they radiate away from the fetch area, get groomed out, eventually turn into swell. Swell, when it hits your beach, turns into surf. So troughs are important. We see a trough on Monday, the 29th of May, in the far southeast Pacific. Again, Southern California, right about here, but you go up off the chart. Oh, and let's get organized here. New Zealand there, Australia here, Antarctica down here, Chile, Peru, Ecuador, Central America off the top of the chart. So a little bit of support for, actually pretty decent support with 130 to 140 knot winds pushing north in the southeast Pacific on Monday night into Tuesday, and then starting to push out of the Southern California swell window on Wednesday, still favoring those South and Central America. As we get into Thursday, a ridge, notice a split jet stream here. When you get this gap like you see here, the dark blue in between the two branches of the jet, that's high pressure. That is would be a counterclockwise circulation. Does nothing to support gale development, and we're not interested in that. Now, as we get into Friday, the 2nd of June, another trough is forecast in the deep South Pacific, pushing north here. That could help support yet another gale right on the hairy edge of the Southern California swell window. Not a whole lot of wind pushing them up into it, so probably not anything too strong. Then it fades. And then as we get into Monday, the 5th of June, you can see the northern branch of the jet here, southern branch of the jet there, piles of dark blue in between, no troughs, no support for gale development until, well, maybe at 180 hours. You get the sense maybe something there, but for right now, model's not suggesting anything solid developing. So let's go down to the surface. Surface level pressure, surface level winds. We see a small gale here, actually two gales. Previous gale, well out of the Southern California swell window. 118 west is right there. That's where Southern California is. Producing 35 to almost 40 knot winds, again aimed at Chile and Peru. New gale developing with 40 knot winds aimed pretty well to the north and in the Southern California swell window. That continues into Monday night, lifting actually north, building some as we get into Tuesday. Then by Wednesday, starting to push well out of the Southern California swell window, but again, still favoring Chile, Peru, Central America up into Mexico, and then gone. And then a high pressure pattern. You see high pressure here pushing the whole way down into Antarctica, kind of just choking things off. Another little gale forecast here on Friday into Saturday, the 3rd of June, with 35 to barely 40 knot winds. There's a little 45 knot winds on Saturday, June 3rd, right on the hairy edge of the Southern California swell window, lifting north and then fading off as we get into Sunday, again favoring Chile and Peru. And then our jet stream pattern starts looking very split with, yes, there is energy. Oh, and there is actually, in fact, another gale forecast on Tuesday, the 6th of July, 180 hours out, the 6th of June, sorry. 40 knot winds aimed off to the northeast. Not sure if I believe any of that, but maybe there's some hope. All right, so what's the effect of those winds on the ocean surface? Today, the 18Z on Monday, the 29th of May. Well, our one system out of the swell window, again, 118 right there. New system developing with 26 to maybe 27-foot seas. Supposed to back build a little bit as we get into Tuesday with 27-foot seas, pushing off to the north. Again, maybe building a little bit more, maybe 28 feet, something like that. And pushing well to the north, right on the hairy edge of the Southern California swell window, with up to, well, I'd say 28-foot seas later in the day, then pushing out of the swell window while building to 30 feet, and then getting solid again, targeting Chile, Peru, Central America up into Mexico, and then pushing east from there. Things go quiet in the South Pacific till we get into, say, Sunday, the 4th of June. Tiny little system. It's so small, I don't even know that would have any significant, not enough of a footprint to generate any swell lifting north. And then we think there's maybe another system here, forecast developing on Tuesday, the 6th of June, but it being a week out, kind of a reach. We'll wait and see. Local wind forecast. All right, so the concern was in last week's video, strong northwest winds along the California coast, mainly north of the Golden Gate, Forecast 30 or 35 knots, creating a lot of wind swell, but the real concern was upwelling and cold ocean temperatures. But examining all the temperatures as of today, things look fine from even Point Reyes on south. So apparently it either did not materialize or did not have as much an effect on upwelling as we were thinking it might. It was really, if it did upwell, was located more up here in Northern California. The point being, it's just where the winds are is where the upwelling is. If the winds, it doesn't upwell further south than that, which is kind of a good news because you'll see why in a little bit. So right now on Monday, a light northwest flow, or even actually it's an eddy flow here, light south winds at 5 or 10 knots, something like that in Northern California. Light trades for the Hawaiian Islands. As we get into Tuesday, more of that eddy flow for North and Central California, and trades for the Hawaiian Islands at 10 knots or so. So we get into Wednesday. Here we go. The north wind machine. High pressure starts building in the southern Gulf of Alaska. Notice low pressure up here. Only 25 knot winds. Probably not going to do anything in terms of swell production. But north wind swell for Central California starting to build on Wednesday. Trades 10, 15 knots for the Hawaiian Islands. So we get into Thursday, 30 knot north winds down to about the Golden Gate, maybe a hair bit south of there. Maybe, and 20 knots off the coast. We'll see. Maybe some upwelling from this on Thursday. So we get into Friday. That fades out, so only maybe a day of pretty strong north winds and some wind swell there. Trades light for the Hawaiian Islands, 10 knots or so. So we get into Saturday, pretty much the same deal, small wind swell. But then we start and trades for the Hawaiian Islands, and then we get into Sunday, and then here comes a stronger high pressure area and building northwest winds along the Cape Mendocino coast. But again, looks like maybe even an eddy flow for Central California for Sunday. So we get into Monday, the 5th of June. Probably okay. Probably not an upwelling setup. Trades for the Hawaiian Islands. See if we can stretch this out. And then even that fades off and lifts north as we get into Tuesday, the 6th of June, with light trades for the Hawaiian Islands. So some wind swell in the forecast. No upwelling. Temperatures not too bad given the time of year. It's now hiking season. We're just doing a quick look at the snow forecast dashboard for the intersection of the Pacific Crest Trail and Tioga Pass Road. So that's up about, 9,700 feet, something like that. In the high country on Tioga Pass Road in Yosemite, theoretically, 1 inch of snow on May 31st. Hard to believe, though. Looking, though, what we're really interested in is snow level, the freeze level for that area. Today, it's at about 10,500 foot. So the big melt continues, but not out of control, just a steady, solid melt. Temperatures, though, or the freeze level starts going up. So this is, if there were precipitation, this is above 32 degrees. The gray is between 32 to 35 degrees. That'd be sleet. So the hard freeze line is right here at about 12,500 feet and continue. So that would be on late on June 1st and continuing from there. So perhaps a bit of a decrease in snow melt right now going on, but come June 1st, that picks up again, and a little bit more favorable increase for melting snow. Of course, waterfalls, that sort of thing, but also dangerous water conditions in rivers anywhere in the Sierra. Use extreme care. Surf spot forecast for Santa Cruz. Small waves, 2 foot, 2.5 feet. This is wind swell here, probably, right in the Wednesday, Thursday thing with all the northwest wind. And then the wind swell slowly fades. This little dip here, that's probably southern hemi swell. In fact, you can see west to northwest winds building this area, then slowly fading off. Looking at actual swell heights, 2 feet at bits of 1.5 feet at 16 seconds, 15. So this is that real south angled southern hemi swell and background northwest wind swell. And then we get, and that continues for pretty much the foreseeable future. Wind swell building to 6 feet at 10 seconds as we get into Thursday and Friday, slowly fading down. But you see this little bit here of 1 foot at 14 seconds. And honestly, that sort of just continues through here. You got to have something more detailed than what this is, but a continued small, very southerly angled southern hemi swell into Santa Cruz. Going south to Dana Point, we see this is all southern hemi swell here, 3 foot, 4 foot, 3 feet, fading down as we get into Friday, the later part of the week, then coming back up in about the 3 foot range. And that doesn't include any effects of the bathymetry for certain breaks that tend to amplify south angled swells. Swell size, 2.5 feet at 15 to 16 seconds, fading to 14 seconds, then coming back up in about the 1.5 to 2 foot range. Another pulse of southern hemi swell at 16 seconds and slowly fading from there. So continued small southern hemi swell. And then going to Maui, again, this is the protection from any wind swell whatsoever. We see surf sizes in about 2.5 foot range, but then pretty much dropping down to near nothing after we get into, say, Wednesday or so. Swell sizes 1.9 feet at 13 to 14 seconds, dropping off down to 1 foot at 13 seconds, then maybe a little background swell 1 foot at 16 to 17 seconds as we get into Monday, but basically the same pattern, everything focused in the far southeast Pacific, kind of bypassing Hawaii, and for that amount, even a lot of breaks in Northern California, really focusing on Southern California, south-facing breaks there, and really down into Mexico and Central America and South America. And then, of course, the tropics. There is a typhoon, Mawar, off of, let's see, the Philippines here. Winds, here's the current position. Winds at 100 knots, so that'd be about 115 miles an hour, slowly making the northeast turn. And that's exactly what you want to see if you're in a El Nino situation. During La Nina, these systems tend to just push right on off to the east, driven by trades, high pressure up here in the North Pacific, and there's no chance for them to recurve. Now, if this recurves, even though it looks like a weak recurvature, and it's pretty much dead by the time it gets south of Japan, still the point being there is some recurvature forecast. It's very early in the season. El Nino, we've been talking about it, but it's not like really established in the atmosphere. But if it were established anywhere, it would be here in the far west Pacific. You notice winds slowly dropping off here, down from 90 knots to 45 knots. That's tropical storm strength out about 4 days from now. Let's go back, though. Now we're going back to Thursday. Here's Guam here. Mawar passed just over Guam. From as best I could tell, is in the middle of an replacement cycle, eyewall replacement cycle. It kind of weakened the system and actually spared Guam reasonably well. But as soon as it got through that eyewall replacement cycle, it really ramped up. Incredibly strong winds, 155 knots. That's 180 mile an hour sustained winds with higher gusts. Well, deep into a Category 5 hurricane. So just sort of a historical point. Very strong tropical system, very warm water here, and westerly anomalies in the Kelvin wave generation area just south of here. Typically, during the active phase of the MJO, and we'll get into all those details in a bit, those time periods are very favorable for tropical storm development, and like a machine, this system formed very strong and is now, like we talked before, off of Taiwan, or forecast to be off of Taiwan and making the turn towards Japan, but far weaker, not as impressive as it was. And we can see the track going out a week on the wave model here. Here's the system currently today on Monday, the 29th of May. See it sort of stalling, the Philippines right along in here. Taiwan, I think, right there. And then slowly making that northeast trend. You see it pretty much falling apart. Looks like even some of the energy got stolen to create or support another low pressure system in the North Dateline region of no real interest. And Marwar, whoops, there we go, last frame, off of Japan, not doing anything really important. But notice there is some low pressure trying to do something. What is that? 13 or 14 foot seas of no real interest. No swell of any interest would be generated for either Hawaii or the U.S. West Coast. But what this does suggest is maybe at least in this portion of the Pacific right in here, maybe there is some El Nino signs starting to show up, where over in here and down in here, it's still La Nina influenced. So we're in that sort of halfway pregnant state where we're partly in El Nino, partly with the hangover of La Nina, and not quite over the threshold yet to be in real El Nino conditions. And with that, let's go take a look long term. What's going on with the MJO, the Madden Julian Oscillation, and the El Nino Southern Oscillation, the two big weather oscillations that have the greatest impact over the Pacific, both north and south, in winter and summer months too, in terms of their effect on swell and surf production. First order of business is examining the MJO, the Madden Julian Oscillation, that periodic weather oscillation that goes across the Pacific. There are two phases, the active phase and inactive phase. Active phase on one side of the planet, inactive phase roughly on the other side of the planet. They rotate around the planet from west to east on the equator. When the active phase of the MJO, which is like a low pressure system, the inactive phase is like a high pressure system. When the active phase pushes over the West Pacific, what it does is dampen trade winds. It also, because it's a low pressure system, increases cloudiness, and also sucks, because it's low pressure, it starts sucking warm water from the West Pacific up into the atmosphere. That in turn gets caught by the jet stream, both north and southern hemisphere, and that can add energy to the jet stream and feed the development of storms in the South and North Pacific, also fueling tropical storm development in the tropical Pacific. All right, so what we're looking for is signs of the active phase of the MJO. This is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. Right there, that is the equator. This is the East Pacific here, like consider this Ecuador. This is on the equator. And in the far West Pacific, there's New Guinea. Okay, we're just looking at the arrows. The colors are water temperatures, but the arrows are wind sensors that are on those buoys. And so the stem here shows you the wind direction, and the longer the arrow, the stronger the wind. So pretty strong easterly trades in the East Pacific, moderately strong trades in the Central Pacific. But when you get into the West Pacific, look at this, almost westerly, not westerly anomalies, actual real westerly winds setting up in the far West Pacific. But it's not the actual wind speed, it's the anomalies, difference from normal for this time of the year. What that suggests, well, we'll take a look here. So these winds pretty strong out of the east, but you look here, they go, well, that's pretty much normal. There's no east-west component of the wind. They're pretty much just like south. Getting the Central Pacific winds, look at this, they're out of the west the whole way into the Kelvin wave generation area in the far West Pacific. So we have we have westerly anomalies almost to a point south of Hawaii. This is the first time this has happened in years, and this is pretty much a typical sign of developing El Nino. If you have at least it's a sign of the active phase of the MJO, and it's a pretty strong one. When you get this, if you have westerly winds blowing over, or westerly anomalies blowing for a continued amount of time over this area, it's what's known as a westerly wind burst. And that helps create Kelvin waves, and we'll get into that in a minute. But basically, it's a way to transport. See this red here? Cooking warm water in the West Pacific starts transporting it east, but not on the surface, but under the equator, following the thermocline. Takes about 3 months, but eventually that ball of warm water, known as a Kelvin wave, impacts the Galapagos Islands and Ecuador and starts bleeding to the surface. if you have successive active phases of the MJO, they can create successive Kelvin waves, which then start warming up water temperatures over in the far east equatorial Pacific. That can help usher in El Nino. So we're very interested in Kelvin waves and the active phase of the MJO for those reasons. So what's been going on in the West Equatorial Pacific for the past 5 days, from the 23rd of May through the 27th of May? All right, so this is just a chart that shows 850 millibar vector wind anomalies, zonal wind anomalies. That is the east-west component of the wind, just what we were looking at. The reds and oranges are westerly anomalies, but we're only interested on the equator. The blues, easterly anomalies. So the westerly anomalies associated with the active phase of the MJO and potentially having the ability to impart energy to the jet stream and the potential to produce a Kelvin wave. So let's get oriented here. South America, Central America, Hawaii is right there. New Guinea is right there. The equator right there. Dateline right there. Kelvin wave generation area from 170 west to about 125 east, 5 degrees north and south of the equator. On the 23rd of May, strong westerly anomalies, westerly wind bursts, continuing on the 24th, 25th, 26th, and 27th. Exactly what we want to see to take warm water that's here, transport it off to the east. So, more data suggesting the active phase of the MJO, and not just any active phase, but a pretty strong one that is producing a westerly wind burst, has been in effect for at least the past 5 days. Good news. So what is the forecast? And can we dig a little deeper into what has recently happened? Okay, so this is zonal wind anomalies, a different chart showing even a longer period of time, looking 2 weeks forward with the GFS model, and then also looking, a month backwards? All right, so this is the east-west component of the wind. The reds and oranges, westerly component of the wind, westerly wind bursts perhaps, what we want to see. The blues, easterly anomalies, the inactive phase of the MJO. Dateline runs right up the middle. Kelvin wave generation area, here's the forecast down here. This is past performance. So from 125 east, that's New Guinea, out to about 170 west, 5 degrees north and south of the equator. Now this is the forecast, but if we look here, what has been going on? Well, we see westerly anomalies sometime pushing into, or started pushing into the West Pacific about May 12th, and then got incredibly strong in here in like the 18th of May through about the 23rd, something like that, and even into today, pretty strong out of the west. This is our westerly wind burst. So it lasted from the 14th to today. So that's 2 weeks of a westerly wind burst. That is certainly capable of creating a Kelvin wave. Now looking forward, per the GFS model, westerly anomalies, forecast fading as we get into about the 5th of June, something like that. And then light easterly anomalies take over. There is one thing to notice here. This is from the GFS model, and it is probably more realistic and more accurate than the CFS model looking out. This is 2 weeks. When you see the forecast from the CFS model, we'll get to that in a minute, you'll see that it's painting a different, little bit too optimistic, too rose-colored glass kind of forecast. So just keep that in mind when we get there, and I'll try to also remind you about that. But this shows westerly anomalies dying by the 4th or 5th of June, and then we go into a weak easterly wind anomaly pattern. Not surprising. So here's another model going out 2 weeks. This doesn't show the winds, it shows cloud cover or lack of cloud cover. Remember, active phase of the MJO is like a low pressure system. Low pressure systems typically generate clouds because they're sucking moist air off the ocean surface, pushing it way up in the air, where it hits colder air and then it condenses to form clouds. So this is outgoing long wave radiation model. Fancy words for cloud cover. Okay, and let's get ourselves oriented. South America, Central America, Hawaii, EQ, the equator. There's New Guinea there, dateline right there. Kelvin wave generation area right in this area. The blue is negative outgoing long wave radiation anomalies, or just means less sunlight bouncing off the ocean surface, cloud cover. So active phase of the MJO. 5 days from now, active phase fading out, inactive phase, which is over the Indian Ocean, starts pushing over the maritime continent, bleeding into the Kelvin wave generation area. And 10 days from now, about a week and a half, inactive phase in control and continuing 2 weeks out and pretty strong. Now, the GEFS model, which is just an ensemble version of the GFS model that I just told you is the one that probably is more accurate than the CFS model, is, and that's this is a statistic model here. It is not the CFS model. It's yet another model. But the GFS model saying basically active phase of the MJO dying to neutral and staying neutral for the next 2 weeks. That's exactly what we'd want to see. A drill down of those two models, statistical model here, dynamic model here. This is the CA model. This is the GFS model. These are phase diagrams, another way to look at the MJO. And they track where the MJO is and how strong it is exactly. So the MJO moves from west to east, from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase of the MJO is today. So in the, we'll say roughly the East Pacific, if the further the dot is away from this circle, the stronger the active phase of the MJO is. So modestly strong over the East Pacific, forecast to move to the Indian Ocean, and anywhere from very weak to moderately strong 2 weeks from now from the statistic model. The dynamic model says active phase of the MJO moving fast to the East Indian Ocean and very weak. So neither of these suggest the active phase to really be where we want it, which is in the west and primarily in the West Pacific and very strong. You want to see the dot up here or the forecast track noodling around somewhere up here, but we do not see any of it. If anything, we see the active phase of the MJO moving to the exact opposite side of the planet. To further back that up, the statistic model, here is a version that shows you areas favorable for precipitation. This is up at the Jetstream level. It works pretty well down at the surface. The greens area is favorable for precipitation. That would be the active phase of the MJO. Oranges and the reds, dry air, the inactive phase of the MJO. This goes out 40 days. Let's get oriented. South America, Central America, Hawaii, that dot right there, New Guinea right there, Equator right there, date line roughly somewhere around there. So this is the Kelvin wave, the all-important Kelvin wave generation area. That is when the active phase of the MJO is over this part of the Pacific, and if it's strong enough, like it has been, it produces those westerly anomalies, then that's a pretty much a sure guarantee you're going to get a Kelvin wave. All right. So today, the greens area is favorable for precipitation, active phase of the MJO over the Pacific, continuing out to about June 3rd, and then pretty much fading, moving into the East Pacific, with the inactive phase of the MJO starting to move over the West Pacific, moving into the Kelvin wave generation, not out of it till maybe early part of July, July 3rd, and then another active phase of the MJO in control then. All right, so next up, the CFS model, and this is back to showing the west-east component of the wind, all on one chart. Date line runs right up the middle. All-important Kelvin wave generation area from 125 east to about 170 west, so right in here. This is past performance here. The solid lines are the active phase of the MJO. Notice the little tropical systems that actually formed. The dotted contour and the blue, the easterly anomalies associated with them, are the inactive phase of the MJO, and notice the lack of tropical development. So we're back in mid-March, inactive phase, early part of April, active phase, pretty good westerly anomalies, maybe a Kelvin wave developed from that. Another inactive phase in the later part of April, and no, certainly no Kelvin wave production. Now our current active phase of the MJO, strong as can be, still in place today over the Kelvin wave generation area, again starting from about there over to around in there. Westerly anomalies in control till about, I don't know, 3rd or 4th of June. Now this model shows the inactive phase building about a week from now and holding for about a week and a half. That's it, with weak easterly anomalies. then westerly anomalies start setting up again. So the CFS model is now starting to pick up on, at least this version of it, is starting to pick up on what the GFS model was showing, specifically those little patch of easterly anomalies. And then finally the CFS model going out 3 months. Okay? And now past performance is down here, and as is always, the forecast up here and the big signal, well, here's the date line right here. The yellows are westerly anomalies. You can just see a wall of westerly anomalies, forecast building. Broken record here. This is what this model has been saying for months now, and really no change. Westerly anomalies, maybe that little patch of easterly anomalies somewhere around June 10th, and then right back to westerly anomalies. Let's overlay the MJO here. All right, again, the date line runs right up the middle here. Kelvin wave generation area 125 east, so this area right in here. Okay, here's our current active phase of the MJO. Forecast fading out, pretty much June 10th, something like that, with a little patch of easterly anomalies. But by the time you get into June 10th, the inactive phase of the MJO is setting up. But notice this, westerly anomalies rebuilding steady, and then you get to about July 6th or something like that. Westerly anomalies start building, and very strong, just pretty much nonstop into August, and building as the active phase of the MJO sets over the far West Pacific. So a very good pattern theoretically coming. It's really going to be interesting to see how much easterly anomalies develop right in here, because if you recall back a couple of months ago, this model had originally shown westerly anomalies starting nonstop here in April. Well, you can see we've gotten a little break, but the breaks are getting, instead of big break, medium break, smaller break, that is the current forecast for our next break. So the breaks are getting smaller, and the footprint of the westerly anomalies and the strength of those westerly anomalies continue to build and get more energetic over time. So just a building El Nino, not a crashing one, okay? And that sort of leads or just teases you just a little bit about what I was asking during the intro to this video. Is El Nino fading or just taking a pause? And you're going to see why I asked that a little bit further in the presentation. All right, but for now, low pass filter. All right, dotted contour, high pressure bias, the La Nina signal. You see it confined now to basically a point south of California, getting weaker and weaker over the next 3 months, and pretty much inland from California before we even get into the start of fall, while the low pressure bias, which has been over Indonesia and the Indian Ocean for 3 years now, the El Nino signal building with 2 contours just west of the date line, forecast building to 3, and I think last week there was even a little 4th contour up here. That's gone now, but effectively 3 contours will be enough to get us where we need to go, and firmly in control before we even get to the fall. Things continue looking good. All right, enough of the MJO. Let's start talking about what's going on down in the ocean. Not at the ocean surface, but down in the ocean. Kelvin waves specifically, and the distribution of warm water from west to east in the East Pacific. Remember I said, Kelvin waves take warm water that's typically in the West Pacific, start transporting it east off of Ecuador. That changes the atmosphere above it through evaporation. That changes the Walker circulation, and that helps set up El Nino. So right now we're looking at data from the TAO buoy rays, those buoys that are strung across the equator, right there. In fact, even there, there's little X's. That's the anchor lines on the buoys. The X's are sensors on those anchor lines. They collect subsurface real water temperature data and then use a model to fill in the gaps, and you get a profile of what's going on in the Pacific Ocean just from 2 degrees north to 2 degrees south of the equator, but the whole way across the Pacific Ocean. So now we see the 28, 29, 30 degree isotherm. This is maybe the second week we've seen this. That's 30 degrees centigrade. That's really warm water. It's pushing east to about 170 east today. The 29 degree isotherm, which was back about 176 west a week ago, now to moving east to 172 22 west. The 28-degree isotherm, now this is kind of interesting. It was up here, and then it was filling the whole East Pacific. Now it's cut off at about 119 west, suggesting water temperatures here not quite as warm as they were a week ago or 2 or 3 weeks ago, and we've seen that. And that is the concern. We're getting into that more in a second when we look at the surface analysis of why are water temperatures not getting warmer over here. I mean, they're not getting cooler, really. The 24-degree isotherm still well in control here, pushing the whole way to Ecuador. Now, it's not the actual temperatures that matter. Again, it's the anomalies, difference from normal for this time of year. The good news is, see 3-degree temperatures here, and there's hard sensors there supporting that thesis that there is a new Kelvin wave building in the West Pacific. Last week, if I recall, it was barely 2 degrees. We still have this gap between the Kelvin waves right here. This is a building Kelvin wave. This is sort of a gap, still 1 degree above normal temperatures. Then you have this massive pool of 5, 4, 3 degrees centigrade, warmer than normal temperatures, and that's multiple Kelvin waves that are all stacked up here and just gurgling. So the pipeline wide open, lots of warm water in it over the East Pacific, and now more starting to build. This is probably not even the result of the active phase of the MJO that's occurring right now, but that one that happened a month ago. So just if this current active phase of the MJO is doing anything, it's only dumping more warm water. So New Guinea would be off here somewhere, dumping that warm water right in behind this, just filling up the pool even more. This is, there we go, another version using a different source, not using the TAO Buoy. This is using satellite data to peer down on the ocean surface and sort of surmise what's happening under the ocean surface. And this tells the same picture. Very warm water in the East Pacific, but notice it's not right at the coast of Ecuador. It's just off of it, a little gap. This also appeared last week as well. Then you have your main flow. Here's the new building Kelvin wave right here. This is the one from, I think it was in April or late March, something like that. In fact, I think it's probably from this active phase of the MJO in April, and now we're into May, and it's made it about this far. So that's about a month and a half. Again, it takes about 3, maybe even 3.5 months to make its way across the Pacific. So this still has another 1-2 months to go to even join up with this big ball of warm water. And this is from 2 at least, if not 3 active phases of the MJO. These are multiple Kelvin waves all just piled on top of each other. You just get the sense, and yet there's another little thing here. We don't know what that is, whether that's an anomaly, but we suspect there's yet another Kelvin wave and warm water starting to spill into the far West Pacific that will be right behind this Kelvin wave. So certainly a string of Kelvin waves marching across the Pacific, exactly what we want to see. This is the raw data that supports that last chart we just saw. This is the height of the sphere of the ocean. Use the Jason satellite, some other satellites, bounce radar off the ocean surface, strip out the wind waves, the swell, the tides, and is the sphere of the ocean, is it higher or lower than normal for this time of, for this time of year? All right. If it's higher than normal, well, warm water depth expands. That'll create a bump on the ocean surface. Cold water depth contracts. It'll create a divot. We see right now, and let's get ourselves oriented. Chile, Peru, Ecuador right there, the Galapagos there. This is the equator. This is the date line right here. There's New Guinea there. You see just steady 5 to 10 centimeter above normal heights of the ocean. A little bit, there's that same gap we saw down in the ocean surface, and then 10 centimeter anomalies here with that little gap right along the coast here. All this suggests warm water, much warmer than normal water at depth, not at the ocean surface, at depth under the equator, the whole way across the Pacific. Now, this is 120 east here. Westerly anomalies right in here will get warm water seeping through the maritime continent here, and then it starts spilling into the Pacific somewhere at depth right in here, creating Kelvin waves. This is the backed off view, just showing you sort of historically what's been going on. West Pacific here, East Pacific here, and going back a year, June. Warm water, Kelvin wave made it across the Pacific. Yes, you can have Kelvin waves in La Nina years, but the exact opposite of Kelvin waves, cold water upwelling, are normally the dominant force during La Nina. And sure enough, right after that Kelvin wave, boom, massive cold water. Oh, and let's get ourselves oriented. That's the West Pacific. This is the East Pacific here. The date line, roughly right there. And 170 west, that's kind of the dividing line. If warm water can make it solidly east of 170 west, then you probably have yourself a Kelvin wave. And sure, we had another one back in November, sort of a warm-up to El Nino. And then in January, February, another Kelvin wave. In February and March, another Kelvin wave. In April, just like the dam broke and the whole, look at all that warm water there, just started flooding off this way. And yet more is there ready to flood across the Pacific. So we are in great shape in terms of the fundamentals for development of El Nino. And there is no change. If anything, the more this continues to sit like this, the better the odds of El Nino development. And we are very, very early in the season to have as much warm water pushing this way as is. That said, in, what was it, February, March, April, May of 2014, we had a similar scenario to this, and then El Nino did not develop. So some of the comments, some of you are saying, well, what are the odds? Is this going to peter out? Is it going to... We don't know. But right now, everything looks favorable for El Nino development. We'll see. The spring unpredictability barrier. During, March 1st through about June 1st, the models have a real hard time knowing what's going on because the atmosphere is in a state of flux. But once you get into June, and the deeper into June you get, the better the models are at predicting what the MJO is going to do and what Kelvin waves are going to do. So we're just about at that point here. Give it about another 2 weeks. We'll have a much better handle on where this El Nino is going, but you all kind of know already what the models have said. Sea surface temperature analysis. And here's the rub in all this so far, or the part that has me a little bit anxious. We'll start with the good news. This is sea surface temperature anomalies, the difference from normal for this time of year. Chile, Peru, Ecuador, Central America, California up there, Hawaii there, the equator right here. The date line is right there. Okay, here is Peru. Warm water. The oranges and red, warmer than normal water temperatures. Water much warmer than normal off this whole area up to Ecuador. Then you see even building up to Baja California. And the trades taking that warm water, dragging it out across the equator. It's out to about 155 west, so about like what it was last week. The issue here is a month ago, or even a couple of weeks ago, this was cooking red. These deep reds filled this area as solid as can be. Then that water got caught by the trades, dragged off this way. Now it's been kind of puttering along. This ball right here is new and warming. That's given us a little hope. But the issue is, why hasn't it stayed cooking warm? It's like the Kelvin wave we know is there. Down deep, there's piles of warm water under here. It should be drawing up or pooling up, erupting to the surface, but it doesn't seem to be. The other thing is trades are dragging the warm water here, dragging it right out along here, which it should, but the water doesn't seem to be like rushing up from down below to fill what's being dragged out this way. And that gives us, I mean, that's really what the crux of the title of this video is all about. Is there a stall going on? I mean, we know we've had the inactive phase of the MJO over here. It's been creating easterly anomalies. And that might be creating some mixing and kind of dampening the effect of the warm waters. We know the active phase of the MJO is coming and westerly anomalies are building like all the way to here. We think we think if everything goes as planned, these temperatures should start increasing in the next week or two and continue from there. In fact, we almost think maybe this pocket right here is the beginning of that increase, but there is some uncertainty. Now recall, there is upwelling along the California coast. That is still the hangover from La Nina. Strong high pressure out here. See the warmer than normal water temperatures here? That's inside the high pressure where there is no air movement or very little. And so the sun starts cooking the ocean surface. But here is that leading edge of those northwest winds. This is like a typical La Nina, kind of a springtime, but a La Nina enhanced springtime pattern. We want to see this starting to fade, and we expect it will as we get sometime into June. Especially, it'll be interesting to see what happens with the northwest winds that are forecast in the next week or so over this area, whether this gets deeper, stays the same, or what. But the concern is not enough really cooking temperatures in here yet. That said, it's very early in the year, and when we get into the historical outlook, we'll see how this compares to the Super El Nino of 97, which was the gold standard. Sea surface temperature trend the past 7 days. Not a big deal. Oh, and here's South America, Central America, Ecuador right there, Galapagos, Hawaii, Equator right there, Australia, New Guinea, you get it. So, warming temperatures, the yellows and orange, weekly warming temperatures out here over the date line, that area. This area has been neutral, if not a little cool, but just in the past couple of days, this finger of warm is starting to develop here. We think that is associated with this building area here, and we think that is all associated with decreasing easterly anomalies in this area, creating, sort of tamping down upwelling, cold upwelling, or mixing, and allowing the Kelvin wave and the warm water subsurface in this area to start advecting up to the surface and creating the typical warm water slick when one would expect during El Nino. That's a guess. 2 or 3 days does not make a trend, but at least it looks like we're heading in the right direction. The overview pattern here, still pretty much the same thing. Lots of warm water, the typical El Nino triangle, well set up here. We're just waiting for it to build. I mean, come on. It's late May, early June. To have even this at this time of year is absolutely phenomenal. So one cannot get too disappointed that it's just not a full-on cooking machine right now. That said, if it continues to fade, that would not be a good sign, especially since we're coming out of the spring unpredictability barrier. One would expect this to start building rather than doing the opposite. We don't know. The models say one thing, and we'll get into that. But again, nature tends to do what it wants to do in its own time. Sea surface temperature trend, and I'll move myself out of the way there. May 28th. So here's sort of the zoomed in bigger image. We're going to go back in time. January 1st of this year. La Nina fully in control. Again, Chile, Peru, Ecuador, the Galapagos, Central America, Hawaii, the equator right there, dateline right there. The blues, colder than normal water temperatures. You see it right here. This is the typical La Nina signal. Cold water in control. We'll just put this in motion so you can see the slow and steady buildup. Notice warm water starting to build even at the end of January, which is pretty impressive. The dying of the southerly trades along Peru. Temperatures building. The first Kelvin wave maybe even starting to show as we get into February. And then deeper into February, little anomaly there. But then as we get into March, temperatures significantly warming. So it's been 3 months now of real warming. Now here is the real cooking warm temperatures that we're interested in. It started March 26th, building real warm, cooking in the early part of April along Peru and up into Ecuador, and then pushing off, getting dragged over the equator to the Galapagos in April 15th. Still solid in April 22nd, but then, well, still continuing into the 29th, but there we go. As we got into May, notice, let's go back. Here we are, April 29th. 1 week later, temperatures kind of broke up. I mean, not warming as much as it was. In May 13th, still kind of broken up, even more broke up on the 20th. And then here we are today. Too early to know if any of this is a sign of something new happening or just a blip on the radar. Hard to say. That said, let's compare this, even in its diminished state, and I'm kind of like, gosh, why isn't it stronger here? Let's compare this to what was going on during May 28th of 1997, which one would consider the gold standard of super El Niños. Looking pretty similar, 97. Just go back. And then 2023. Looking a little bit warmer maybe right here, but notice the overall coverage here of the 97 El Nino. It's a very thin stream of warm water confined to, really, it's not even contiguous out to 160. It's just light. Where we go to this year's El Nino, fully solid the whole way out to 155. So kind of hard to, complain too much, because I'm thinking that right now the footprint, look at the coverage out in here compared to, that's today, compared to this broken up kind of coverage. Doesn't even, it's in pockets, but one can say this warm water isn't even really El Nino related off of Mexico, just seasonal warming in 97, where today it's solid. The whole area from Peru up to Baja and out to the dateline looks like an El Nino anvil. So, the point being, a little bit concerned that it's not as warm as it should be. But given that there was just a inactive phase of the MJO over this area, enhanced trade winds, probably not surprising that things have tamped down. We'll see in the next week whether warming starts building off of Ecuador and the Galapagos. Just too early to know. Sea surface temperature trend here in the Nino 1.2 area. This is the area right there along Ecuador and the Galapagos. Well, temperatures today at plus 1.988 degrees above normal. Right there. You can see the little dip in temperatures going back a week. For the most part, here's when it peaked out, like somewhere in mid-April, something like that. But still, just sort of toggling around between 2 to 3 degrees above normal. Bottomed out a little bit here just a week ago. Now we're starting to climb back up. We think we're on the path to redemption, but still too early to know. Temperatures in the Nino 3.4 area, same basic trend. They peaked up. They were half a degree above normal. We kind of made a big deal out of it. Finally, we're there. It lasted all of about 3 days. The threshold for El Nino is half a degree above normal. That would have been right here. We'd made it for 3 days, and then we've just been in a long run of not there. But today, back to 544 thousandths of a degree above normal in the El Nino range, in threshold, above El Nino threshold, but 1, 2, 3, 4 days of that certainly is not a trend. It has to be for above half a degree above normal for like 5 consecutive months to be officially El Nino. So we're not there yet. We are ANSO neutral, and that really is the thing. Part of the Pacific sort of starting to smell like El Nino. Part of the Pacific still clearly looks like La Nina, and so we're slowly, the pendulum is swinging, but we're not there yet. So that brings up the question, what does the atmosphere think is going on? Rather than qualitatively me trying to make my best guess, there are some numbers that give us a clue. That is, we look at the difference in pressure between Darwin, Australia, over the Indian Ocean, Tahiti, and the Pacific Ocean. And if Tahiti has lower than normal pressure relative to Darwin, then we'd say, hey, maybe we're moving towards El Nino, at least the active phase of the MJO. If the pressure is higher than normal over Darwin, then over Tahiti, then we'd say that we're in the inactive phase or La Nina. If we're in the active phase or El Nino, these values are negative. So today's value, pretty much neutral, minus 0.82. But, big but, look where we were just a couple of days ago. Very deep in negative territory, minus 64.63. And then even a little bit before that, we were down at minus 31.31 in May. And the trend has more been more negative than positive. That's a good sign. The 30-day average SOI, minus 13.85. Hey, that's good news. Where were we a month ago? Minus 1. So this is steadily dropping, suggesting lower pressure is building over the Pacific. Remember the low pressure bias chart that we saw in the CFS model, suggesting also that low pressure is building over the Pacific. This confirms that. The 90-day average, which is sort of looking back 3 months, but this is the active-inactive phase of the MJO indicator. When you see this dropping like this, that would suggest the active phase of the MJO is in control. The 90-day average is your La Nina El Nino indicator. Today, minus 5.77, falling. Where were we a month ago? Plus 2.41. All indicators suggest pressure is falling in the Pacific. Let's go look at a graph. If ever a picture tells the story, this is that picture. This is the 30-day moving SOI graphed out. Going back to January 2021, the downward spikes are the active phase of the MJO, the upward spikes the inactive phase of the MJO. You can see the trend line going steadily positive, suggesting the inactive phase of the MJO is stronger than the active phase. That means La Nina in control. And then we held there into January 2023, and then what is this? Just almost one long continuous. It's actually 1, 2, 3 active phases of the MJO, pushing the 30-day average down to almost minus 15. We are still in the active phase of the MJO, so we expect this to go even lower. Eventually, we're going to get in the inactive phase, and we'll sort of probably bobble around somewhere around here, and then we expect to fall precipitously deeper into this negative territory over the next month or two. So, all indications right now suggest atmospherically, the atmosphere thinks we're moving towards El Nino. It's not saying that we're in it. And then the deal is, can the ocean, all that warm water, all those Kelvin waves, all the active phases of the MJO driving them, become coupled with the atmosphere above it? If the ocean says we're in El Nino and it's doing all the right things, and pressure gets low enough and enough warm water starts building up off of Ecuador, that will continue to drive this number negative, and eventually the North Pacific and the South Pacific will become biased towards low pressure, and bingo, there you're in El Nino. Right now we're not there, but all the signs suggest we're moving in that direction. One last piece of data real quick. The current, ocean current on the equator. South America right there, Central America right there. You can see the current right in Ecuador, and that's sort of pushing off to the east. And here's the Galapagos here. But then from there, from wherever that is, let me see, I can pull the number up, 148 west. So basically, Hawaii, we'll pull Hawaii right in. Okay, there you go. Westerly current, well in control, a little bit of anomaly right here, but westerly current in control. Now, what's really good is, let's go over here and look. Here is the maritime continent right here. Look at the strength of the westerly current. You think that isn't taking piles of warm water that's all building and being drenched by the sun in the shallower waters of the maritime continent and driving that into the Pacific Ocean. This will fall to depth and then follow the thermocline. Now, this is just current, and we assume these are warmer than normal temperatures here, probably much warmer than normal ocean surface temperatures. That'll help create yet another Kelvin wave that'll push its way across the Pacific. Point being, the equatorial current is steadily building out of the west. When you're deep in El Nino, it's just like a river flowing this way, the whole way across the Pacific. We're not completely there yet, but certainly things look very favorable. And that westerly wind burst in the West Pacific has certainly affected the current here and doing a lot for one, creating that typhoon Marwar with 180 mile per hour winds sustained. Impressive indeed, and likely driving another major Kelvin wave to be formed. All this is looking good. Finally, sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region, as rendered by the CFS model version 2. All right, so where are we? We are in May, almost June, so June would probably be, that's April, May, June would be here. So this is mid-May, somewhere around here. Temperatures barely in the El Nino threshold, forecast building to 1.4 degrees in July, mid-July, and up to 2.1 or 2.2 degrees in October, November, and December. That would be your peak of El Nino, with the coupling with the atmosphere in the jet stream only getting stronger as this happened, with probably a 2-month lag after that, meaning the jet stream just ripping as you get into late January and February. Now, this is the non-corrected data. This is the more probably optimistic view. PDF corrected data showing a similar picture, but oops, there we go. In July, temperatures up to 1.1 degrees and then going up to about 1.75 degrees as we get into December. This is probably a little bit on the low end of the scale. We'll just have to see, but the model still saying El Nino coming, and all the other models pretty much saying the same thing. So for right now, small southern hemiswell, very south angled relative to California, almost east of the swell window for all but the more exposed breaks in Northern California. Certainly good for exposed south basin breaks in Southern California. Certainly good for down into Mexico, Central America, and Peru on down into Chile. And more of that coming, maybe not as energetic as what we've seen, but still steady, very south-angled swell is forecast. A little bit of a break is forecast, maybe a week and a half, 2 weeks out, something like that. But the models have been continuing to say that, and then out of the blues, somewhere some new system forms, and the pattern just continues. All this, though, suggests this is hangover from La Nina because the storm track is so far east or southeast centered. So that suggests El Nino not dug into the atmosphere yet. We don't really expect that till maybe the later part of July. And then at that time, maybe, just maybe, if the ocean and the atmosphere become coupled and Kelvin waves continue and that warm water builds off the Galapagos, then maybe we'll start seeing some activity under New Zealand. But until then, we're just keeping our fingers crossed. Too early to know if there is something going on with El Nino. We think, though, by and large, whatever is happening, the little stall that's happening at the moment is just a temporary blip. It would not be unusual. And we expect the machine to crank up into high gear. Maybe it's already starting to do that now. All right, that's the video for this week. If you enjoyed it, give us a thumbs up. We appreciate it. If you have comments or questions, just write them down there. We'll try to respond. If you're thinking it, 10 other people are too. So no question is a dumb question. Don't be scared. We're friendly here. All right. And other than that, we're going to try to do this. It'll probably be not next Sunday, but next Saturday, because we're out doing some other things, trying to chase things. But yeah, there'll be a video later this week, Saturday rather than Sunday. So we'll let you know of any trend that develops between now and then. All right, that's it for this week. Signing off. We will see you on Saturday. Take care, get some waves, have fun. See you soon.